For this problem, we're going to take a look at this function in polar form. R is equal to 1 plus sine theta cosine theta. Graph is down here. First part of the question, find the value of theta between 0 and 2 pi at which R is maximized. Okay, so the way that we typically do this problem in calculus is we check the endpoints, we check the critical points, and we'll see what happens. So let's do that right now. So the endpoints, R of 0 will be 1 plus the sine of 0 plus the cosine of 0. That's equal to 2. R of 2 pi is equal to 1 plus the sine of 2 pi plus the cosine of 2 pi, and that is also equal to 2. Okay, next we check the critical points. So we figure out where dr d theta is. Dr d theta is equal to derivative of 1 is 0, derivative of sine of theta is cosine of theta. Derivative of cosine of theta is negative sine theta, and we set that equal to 0 to figure out the critical points. And so that gives us that cosine of theta is equal to sine theta. And to get this down to one single trig function, we get that the tangent of theta is equal to 1. And that's one of our common angles. And so that between theta and between 0 and 2 pi, pardon me, there are two solutions, pi over 4 and 5 pi over 4. And so we check those critical points. We get R is equal to R of pi over 4 is going to be equal to 1 plus the sine of pi over 4 plus the cosine of pi over 4. And that is 1 plus the square root of 2 over 2 plus the square root of 2 over 2. And so that's 1 plus square root of 2. The other one, R of 5 pi over 4, will be 1 plus the sine of 5 pi over 4 plus the cosine of 5 pi over 4. So 1 minus the square root of 2 over 2 minus the square root of 2 over 2. And so that's 1 minus the square root of 2. And so looking at our four options, 2, 2, 1 plus square root of 2, 1 minus square root of 2, this is the one that gives us the maximum. So find the value of theta at which R is maximized. The answer is going to be theta is equal to pi over 4, and R is equal to 1 plus square root of 2. Okay, and just for the sake of looking at it, so here's the graph of the function. So here we see the 2. So at angle 0, pardon me, we're 2 away from the origin. Here at pi over 4, this would be angle pi over 4 here. And so in polar coordinates, this would be 1 plus square root of 2 pi over 4. And for what it's worth, the height of this inner loop is what corresponds to the minimum. So we found that the minimum value was 1 minus square root of 2 when we had an angle of 5 pi over 4. That would be 5 pi over 4 would be this direction, but I go backwards. So this would be square root of 2 minus 1 away from the origin, or 1 minus square root of 2 if I went in this direction, but going backwards. So I can just point that all out for the sake of the review. All right, point number 2. Express the point P in both polar coordinates and in rectangular coordinates. There it is in polar coordinates, 1 plus square root of 2 pi over 4. So that's the point in polar coordinates. So that's the point P in question. If I express that in rectangular coordinates, that would be x would be equal to r cosine theta. So 1 plus the square root of 2 times the cosine of pi over 4. So 1 plus the square root of 2 times square root of 2 over 2. And so that would work out to be 1. So square root of 2 times square root of 2 is 2. Divided by 2 is 1. And the other one would be square root of 2 over 2. The y-coordinate would be r times sine of theta. So 1 plus the square root of 2 times the sine of pi over 4. And that is the exact same thing because the sine of pi over 4 is also square root of 2 over 2. And so that also works out to be 1 plus square root of 2 over 2. So in polar coordinates, the point is 1 plus square root of 2 pi over 4. In rectangular coordinates, it's 1 plus square root of 2 over 2, 1 plus square root of 2 over 2. The x value and the y value are the same, and that makes sense because this angle here is pi over 4. And so it makes sense that on this line, the x and y coordinates are all the same. Okay, part 3. Find the slope of the tangent line at this point P. Okay, so to find the slope of the tangent line, let me cover this up for the moment. Our formula for the tangent line is that dy dx is equal to dr d theta times sine theta plus r times cosine theta all over dr d theta times cosine of theta minus r times sine of theta. Okay, now in this problem, my r is equal to 1 plus sine theta plus cosine theta. And so that means that dr d theta will be equal to cosine of theta minus sine of theta. And so plugging in, we would get cosine of theta minus sine of theta times sine of theta plus r, 1 plus sine theta plus cosine theta times cosine theta all over cosine theta minus sine theta times an extra cosine theta minus r, 1 plus sine theta plus cosine theta times sine theta. Okay, now I need to plug in pi over 4. So the maximum occurred when theta was equal to pi over 4. And so I plug in pi over 4 now to figure out what the equation of the tangent line is when the r is maximized. So I would get cosine pi over 4 minus sine pi over 4 times sine pi over 4 plus 1 plus sine pi over 4 plus cosine pi over 4 times the cosine of pi over 4 all over cosine pi over 4 minus sine pi over 4 times the cosine of pi over 4 plus 1 plus the sine of pi over 4 plus the cosine of pi over 4 times sine of pi over 4. Okay, now both sine and cosine pi over 4 are equal to square root of 2 over 2. Square root of 2 over 2 minus square root of 2 over 2 times square root of 2 over 2 plus 1 plus square root of 2 over 2 plus square root of 2 over 2 times square root of 2 over 2 all over square root of 2 over 2 minus square root of 2 over 2 times square root of 2 over 2. And I'm sorry, that should have been a minus here. I apologize. Minus 1 plus square root of 2 over 2 plus square root of 2 over 2 times square root of 2 over 2. Okay, now this looks like a hideous mess, but a lot of things are going to go away. This right here, both of those are 0. And so we can just simply ignore those. So let me copy, so I can drop off this term here because that's a 0. So, so let me copy over 1 plus square root of 2 over 2 plus square root of 2 over 2 times square root of 2 over 2. Then I have a minus 1 plus square root of 2 over 2 plus square root of 2 over 2 times square root of 2 over 2. And I shouldn't have had a parentheses there. Now I could simplify, but I noticed that everything cancels. And so this works out to be just simply negative 1. And so the slope of the tangent line At that point, it works out to be -1. Okay, so coming to up here, the slope of the tangent line, this works out to be -1. 4, confirm that the tangent line at P is perpendicular to the line segment connecting P to the origin. So here's the tangent line. And this has slope of -1. Here in pink is this line segment connecting P to the origin, and the slope of this line is 1. The rise over the run is 1. Said another way, the tangent of pi over 4 is 1. So here I have a slope of 1 and I have a slope of -1. And so if I multiply those together, so note that 1 times -1 is equal to -1. And that's one of our properties from geometry. If I have this two lines, and if I multiply their slopes and their product is -1, that confirms. And so the two are perpendicular. If the slope of the first line times the slope of the second line is equal to -1, then the two lines are perpendicular. And so that confirms that the tangent line here is perpendicular to this line segment